The scientific notation is a way of writing numbers, especially very large numbers or very small numbers, in a more compact and manageable form. A number in scientific notation has the form of a product a times 10 to the nth power. Number a can be positive or negative, and the absolute value of this number has to be greater or equal to 1 and less than 10. In scientific notation, we use this symbol for multiplication, and the exponent n can be any integer. And integers are whole numbers that can be positive, negative, or 0. One example of a number in scientific notation can be 9.5 times 10 to the negative 4th power. Another example, negative 7 times 10 to the 3rd power. In both these examples, the absolute value of each of these numbers is a number that is greater or equal to 1 and less than 10. And absolute value means the positive of a number. So the absolute value of 9.5 is still 9.5, and the absolute value of negative 7 is 7. Also, in both examples, the exponents are integers, so we can say that both these numbers are in scientific notation. Now, let's see how we can convert numbers from standard notation to scientific notation. So here we have the rules, and now let's say we have the number 25 million. This number is in standard notation, and some textbooks also call it ordinary or decimal notation. Because this is a whole number, the decimal point is to the right of the ones place, and we just don't display it if there are no decimal digits. Now, to write this number in scientific notation, we need to move the decimal point so that we can get a number that is greater or equal to 1 and less than 10. In this case, we will move the decimal point 7 places to the left to obtain the number 2.5. So now we have 2.5, and we need to multiply this number by 10 raised to an exponent. And the exponent represents the number of places the decimal point was moved. If the decimal point was moved to the left, then the exponent n is a positive number, but if the decimal point was moved to the right, then the exponent n is a negative number. In this case, the decimal point was moved to the left 7 places, therefore the exponent will be positive 7. Now let's convert the number 0.0000478 to scientific notation. In this case, to obtain a number that is greater or equal to 1 and less than 10, we need to move the decimal point to the right. So we will move the decimal point 5 places to the right to obtain the number 4.78. And indeed, this is a number that is greater or equal to 1 and less than 10. And now we will multiply this number by 10 raised to an exponent. And because we moved the decimal point 5 places to the right, the exponent will be negative 5. Now let's try one more number, negative 74,000. So again, here we have an integer and the decimal point is to the right. So then we will move the decimal point to the left to obtain a number whose absolute value is greater than or equal to 1 and less than 10. In this case, we will move the decimal point 4 places to the left. So now the number obtained is negative 7.4, and indeed, the absolute value of this number, or the positive of this number, is greater or equal to 1 and less than 10. And now we will multiply this number by 10 to the 4th power, and the exponent is positive because we moved the decimal point to the left 4 places. Now, let's see how we can convert numbers from scientific to standard notation. Here we have the rules, and we will start with the first example, 2.89 times 10 to the 6th power. According to the rule, because the exponent is positive 6, we will move the decimal point 6 places to the right, and we will add zeros if needed. So we have 2, 8, 9, and we will add 4 more zeros. So the decimal point was between 2 and 8, and we moved it 1, 2, 3, 4, 5, 6 places to the right. And now 10 to the 6th power is gone, and we have the number 2,890,000. In the next example, we will have 5.1 times 10 to the negative 2nd power. According to the rule, because the exponent is negative 2, we need to move the decimal point 2 places to the left. And again, we will add zeros as needed, and we will obtain the number 0.051. So the decimal point was between 5 and 1, and now we moved 2 places to the left. And now let's see one more example, and that will be negative 8.23 times 10 to the 4th power. In this case, the exponent is positive 4. Therefore, we will move the decimal point 4 places to the right. So let's carry the negative, and then we will have 82,300. So initially the decimal point was between 8 and 2, and now the decimal point is 4 places to the right. I hope you enjoyed the video, and thank you for watching.